So, good evening to all. So today I will be talking about raster
This
data
conference will
processing
now be
in
recorded.
Python. So I will start with, so this is my outline of the lecture. Initially, I will start with raster data basics. What is raster data? Then I will introduce you to the GDAL library. Then we will how to read a raster data, write raster data, when stacking multiple bands together and creating a multi-band image or creating mosaic of raster images. These topics I will cover during the course of lecture. So what is raster data? Raster data is a matrix of cells or whatever you call pixels organized in rows and columns. So here you can see that this is a full image. This is just the small portion of the image. If we zoom in to this portion, you will see an image array of matrices like this, where every pixel, this is a cell of matrix of cells organized in rows and columns. So here every cell will contain a value. So this value may represent some temperature, or if it is a digital elevation model, it may represent elevation, or it may be a reflected energy. So here you can see that some cells are white in color, some are different shades of gray color are available. So this, in computers memory, these darkness of these cells is represented as numbers. So here you can see that number 255 represents white cell. So if the cell is completely white, then its value will be 255. Or when if the cell is completely black, it represents a number 0. So an image in computer's memory looks like a two-dimensional array of numbers. So this is our raster data. So satellite images, aerial photographs, or any digital photograph that is stored in computer's memory generally is a raster data. So these are the raster bands. Actually, a raster image can contain a single band or it could be multi-band image. So a single band raster image can be represented by like a binary image. So every pixel may be either 0 or 1. So this will be a binary image, or it could be a grayscale image. In that, if suppose it's an 8-bit grayscale image, a pixels value will be from in the range 0 to 255. So 255 may represent completely white and 0 completely black. Or a single band image we could represent like and display like a color table. So here suppose if it is a classified image, so all numbers 1 can be represented with some color. All number whichever pixels has value 2, that could be represented with some different color, or so and so on. And third, image can have more than one band. So that is called a multi-band raster. So suppose this is an image, it has 3 bands, red, green, and blue. When we combine all 3 bands together, then we get a true RGB image. So that is the image. What do we look? Otherwise, if we see just the image in red band or green or blue, we will see just a grayscale image only. When we combine these all 3 bands together, then RGB, then it becomes a true color image. So this here you can see that these are the 3 grayscale images. These may be in different bands. When we combine all these bands together, we get a true color image. So for reading and writing, I will introduce you to GDAL library. GDAL is used for all raster, vector, even network processing. Also, it supports almost all of the raster and vector data formats. This is a general data model of GDAL. So if you open a file with GDAL library, it will return you a data set. So that data set will contain multiple. It contains multiple bands, and the geo transform information about an image that I will come later. So in every band will contain data array and overview of that band. Suppose if your image is very large and you are displaying it, then the reduced image will be shown to you. So that is the overview of the image. So raster coordinate system. Actually, for displaying an image suppose we have taken an image and now we want to display it on a map. So for that we need to attach a special reference system to every image so that it can be displayed on a map. Otherwise, we don't know which portion of the earth that image is. So suppose if you have to project it on a map, we need to attach spatial reference system to it. So spatial reference system of an image consists georeferencing and coordinate system of that image. So this is required for overlaying an image on the map. So coordinates of upper left corner, this in image upper coordinates of this upper left corner and the pixel size and how much it is rotated, that is stored with every image so that it can be projected on a map. So this information like upper left corner, coordinates of the upper left corner and pixel size, and this how much amount of rotation is stored, that is called affine transformation. With that we can calculate coordinates of every pixel. So we have stored, we just like this here, you can see that we have just stored the coordinates of this top left pixels x and y. Suppose this is x0 and y0, and if the pixels is x, px is in x direction and py in y direction. So then we can easily calculate what will be the coordinates of this pixel. So this pixel will be, because this is 4 columns to then 3 rows. So this will be x will be x0 plus 4 into px, and y will be y0 minus 3py, because in generally we take coordinates here 0 0, but in computer's memory 0 0 will be this coordinate. So y is in negative direction. So this is the basic introduction to what raster image is. Now I will demonstrate the code, how to read and write raster data using GDAL library. So whatever code I will demonstrate here, it is just for demonstration purpose. It is not some production code, so it will not be optimized. So it's just for demonstration. Because you can write. This is not the best way to write a code, but this is what because of demonstration I have kept it very simple. So first thing, actually for this we need to import the package from OSGeo is the package for GDAL. So from OSGeo package we will import GDAL library, GDAL module, and NumPy. Anyway, NumPy I think has been introduced to you. So we need GDAL, NumPy, and Matplotlib is just for plotting the image. So first we will import all 3 packages, GDAL, NumPy, and this. Now I have defined a file name here. So I have kept an image in this location, G drive, Gangkotri, list 3, and this is some part of Uttarakhand. This is a list 3 image. So I have defined a file name variable. Now I will open with gdal.open. Suppose if you want to get some help on this function, first we will use gdal. So you can in notebook you can do like this. So it displays you the help of the function. What does it do? In this they have not maintained this. Some other function I will show you. This course. So first thing we will show gdal.open. So here we will pass it takes 2 arguments. First is the argument is the file name, and second is in which mode you are trying to read it. So gdal.read only. So if we do this, this will return us a data set. So there I show you in the data model, the data set. So it returns a data set. So if now I will check if data set, if there is some error in reading, so data set will return none. Otherwise it will return one data set object. So here we will check if not data set, error in reading the file. So anyway, so it has not printed any error. So it means that it could read the data successfully. Now we will, from the data set object, we will get some basic information about the image. So first, dataset.get driver, it dot short name, it gives the description about the driver which opened the raster image. So if I run this, it will give that it was a GeoTIFF image. So if it is an ADAS image in IMG format or something, so depending on which driver it has used, it will print this. Now this with dataset dot raster x size and dataset dot raster y size, you will get the dimension of the image. So if I print is this, so this was a 1151 by 1151 image, one square image. So dataset dot raster x size and dataset dot raster y size will give you the dimension of the image. So many functions are available. This so you can get with this. Suppose if you give tab here, so it gives all the function, all the methods available with dataset object. So you can get all help on the notebook. So you can get all the information. And if you like raster, so with shift tab, you get the help about the function, what argument it takes, what does it return and all. So dataset dot raster count, this gives how many bands are available in that image. So this was a single band grayscale image, so it returns a number 1. So there the image is a single band image. Now dataset dot get projection, with this we get what projection is used with the image, in which projection system the image has been stored. So here we can see that the projection of image GeoGCS. So this is geographic image data is stored in geographic coordinate system and the WGS datum. And now we get the transformation, affine transformation information from the dataset about the image. So if you dataset dot get geotransform gives us the geotransformation information about the image. So if we print this, this gives a six elements. So this is giving origin. So this origin means this is the coordinates of pixel number 00. So pixel number 0's coordinates are 78.99 and 31.00. As we know that because the image was in geographic coordinate system, so these are in degrees. So here it shows in degrees, or the unit of the coordinates are in degrees. And pixel size in x direction, pixel size is 0.002 degree, and y size also is same point, minus 0.002 degrees. It corresponds, I think, somewhere around 50 meters resolution. And rotation is 00 means if in the image is not at all rotated. So north is in the up direction. Now with this we got the all basic information about the raster image. Now we will read the data from the image, as I showed in earlier, because image is a matrix of numbers. Now we will retrieve the numbers from that image. So every pixel has a digital number or reflectance value that they call DN value. Now so we will retrieve that number. So first we will get the band. So for that dataset dot get raster band, this fetches the band. So argument, this will take the argument which band you want to fetch. So this will be like if image is 3 band, so you have to pass 1, 2 or 3. Indexing starts here with 1, not with 0. So if you want to read the first band from the image, you need to pass it number 1. If you want to read the second band, you need to pass it number 2. So dataset dot get raster band will get us the band. Now we have the band information from the image. Now I am printing get data type name, because that image how the numbers are stored. So here it says uint16. So every pixel's intensity is stored in 16-bit unsigned integer. So the pixel intensity can vary from 0 to 65535. Or suppose if the image is 8-bit, then it will return uint8, or if it will be floating point number or anything. So suppose if you want to compute some minimum and maximum, what are the minimum maximum intensity values in that whatever image you have read, so with that band dot compute raster min and max, it gives us the min and max values. So this returns us 43 and 695. So minimum pixel intensity is 43 and maximum is 695. So with get raster band, we have retrieved the band. Now we will read full array. So if from band dot read as array, this reads full array and it will return you a numpy array. So if you see, this was the image what we have shown. So these are the all pixel data, digital numbers of every pixel. So now I will just plot it with matplotlib. How does it look like? So this was the image of Gangotri. So you can see that. So if we plot these numbers, we get an image like this. So after you have completed the reading of image, now you can close the image. So for that, either of these two steps you can follow, either assign none to the dataset or delete that dataset. So this is the way how do we read, and I just read and raster image. I will just quickly recap it. So first thing is we need to gdal.open. There we need to pass the file name which you want to read. So with that you get a dataset object. So dataset object contains the metadata or everything about an image. So with this dataset you can get the basic with raster.x size, raster.y size, raster count. With that you get the basic information about the image. And suppose if you with dataset.get projection gives you the projection information, get geotransform gives you a transformation, affine transformation information of the image. And with get raster band, with get raster band and pass the which band you want to read. With that you get the you retrieve the band of that particular band of that image. Then that band you can read as an array. So this will give you the numbers. With that you get the numpy array. Now on this numpy array you can do any type of processing, like if you want to apply filter, whatever you want to do, these are the numbers. These numbers you can do whatever type of processing you want to do. So with matplotlib you can just plot.imshow. With that you can plot the image. So then you have to close the data set. Now suppose this was a single band image. Now if we have a multi-band image, so multi-band image also we can read same way, but only thing that we need to retrieve the all bands one by one. So here I have a same Gangotri's colored image available here at this location. So I will read and show you how do we read a multi-band raster. So same I have specified the file name, then gdal.open will get the dataset. If dataset is not none, then we get the information about it returns the dataset and dataset. This is also gtif. So now here if we get dataset dot raster count, so here it will return 3. Earlier it was returning 1. This is because the 3-band image RGB is available, so it returns a 3 number. So now here this is just for plotting. So here for I in range 1 to bands plus 1. As I told, here in the band index starts from 1. So from 1 to 4, this is a for loop. It will generate numbers from 1 to 3. So first thing, band dataset dot get raster band. So here we will pass the argument I, band number, the band which we are retrieving. So data will band dot read as array. So this will return the data numpy array. Now with this we can plot the image plot. So if I show it, so we can see that this image, because these all are looking similar, but because pixel intensity doesn't change, but this represents a red band, this is green band, and this is blue band. When we combine these all together, then we get the true color image. So with this loop you can read. Now we have seen that all three things are written. Now suppose with this portion 3 different arrays are available. Now if I will stack these arrays. So with this we can see here itself. Otherwise we can see in any other GIS software, maybe QGIS or ArcMap, these images. So if we do this portion, this is the actual true color image. So when these all three bands were combined, with this we get this true color image. So here what actually directly if you do dataset dot read as array. Before that I was first retrieving the band from the dataset. So then from band I was reading an array, or otherwise you can directly read from the dataset also, read as array. Then it will give you a, suppose if I show here. So here you can see that. So we can read the pixel DNs from the dataset in two ways. So first we can fetch the particular band. Suppose if you are interested in some green band, red band or blue band. So then you can fetch that particular band and band dot read as array. It returns you an array, or directly from data, or directly you can read as array from dataset itself. So if you do dataset dot read as array, then all bands it will read together. So here you can see that it has returned us a three-dimensional array. So this is a three-dimensional array. So if you do on this zeroth element, so this will give you a first band, second band, and third band. So this is a three-dimensional array. So this is a three 11151 by 1151 three array, three two-dimensional arrays of 1151 by 1151 size are available. So either you can read fetch a particular band, then from that band you read as array, or directly from data set also you can read as an array. That will return you full array. So after reading is over, same thing. You have to delete the data set and now this is the reading part. Now I will demonstrate how do we write a raster. So for writing a raster dataset, first we need to define the file format in which you want to write the data. So suppose if you want to write in TIFF format, so file format these are some short names for the drivers that are available in JIDA's website. For GeoTIFF, you need to specify the file format as at GTIFF is the short name of the driver. So file format you will define at GTIFF or HFA, NetCDF or whatever file format available. Then we need to create a driver. So JIDAL.getDriver by name. So we need to call this function getDriver by name. Here we need to pass on the name of driver which you want to create. So here I want to create a driver for writing an image in TIFF format. So I pass the file format name as gtiff. So driver gdal.get driver by name and file format. It creates a driver. So with this driver we can write an image. So there are two ways to write an image. Either we can use create copy or directly create. Create copy, suppose if we have already an image. In that image, all geo transformation, projection, every information is available, and that information we want to copy to a second image. Like we read an image, we have done some processing on that image, and we want to save the image in same projection with that image, same projection information and transformation is also. Then we can use create copy. Suppose if we are creating a new image and we know what is the geo transformation and how do we want to project the image, then we can use the create driver.create function. So first I will show you how do we use create copy. So here we have I am defined a file name, source file name. So from this file I will copy to a new different file. So actually this you can use for, suppose if you want to change the format of file, you have a TIFF file, you want to convert it into a IMG file or some other format. So for that also you can use the create copy function for changing the format from one format to another format. So first I have defined a source file name. This is band2.tiff. Then this file I will copy to a different file like band.copy. So here this band2 image is there. With this function, it will write a new image with name copy to this folder. So first thing, anyway, we have to open, because we have to copy. So first we have to source dataset, jdr.open this source file name. This will open this file for reading. Then on whatever driver we created, on the driver.create copy. So this method we need to call driver.create copy. Here we need to pass the two arguments. First is the destination file name to which this source data will be copied, and the source destination. It takes two arguments, destination and source. So it will create a new destination, data set that we can write. So destination file name and this. Now from the source data, I'm reading the first band, then reading it as an array. Now you can see that this will look like. So this is the actual data. Now in this data, on every pixel's value, I am just adding 10 to every pixel value. Or you can do any other kind of processing. So now you can see 57 has become 67. So I've just modified the array, and all other information remains same because all the projection information and transformation and everything is in the image is same. Only thing, just DN numbers I have just modified. So then this was the band, then write array and pass the numpy array which you want to write. So out underscore band is the band which so this is on destination. This is the band one of the destination data set out band. So out band dot write array, this data I have written to the out band. So after you have written the data to the out band, then you need to flush the cache. So it will write to the disk. Till now it is in memory only. With flush cache, it will go to the hard disk. After that, you just need to just close the destination dataset and source dataset. So with that, the file will be written to the disk. And if you can see, it will be available here. So dot copy has been created here. I have dot img. I have made a mistake. So here now it has become an img image. You can open in QGIS or so this is the copy of the image. This is how do we write a image. So original image was in GOT format. We have changed it to the img format. So quickly sum up. So I've copied using. So first thing we need to suppose if you know that you have already a source data set. On that only you want to do some processing and write it to the disk. So you can conveniently use the create copy. You need not write geo transformation and other information separately or no data value. So directly you can use create copy method, pass it your destination file name, where do you want to write, and source data set from which you want to copy the information. So you read and do your processing and write the image. Now second method is create. So here I will be using I will write data plus some spatial reference information like projection and transformation information also to the image. We will create an spatial reference system and attach it to the file. So for that, actually from OSGeo packet, we need to import OSR, that is OSR spatial reference, spatial reference system. So first same way I have defined a file format. I want to write an img format. So same way I will driver.gdal.get driver by name. First, this is the first, we need to create a driver. This is the first step. And anyway, source data set is not required here. We are not copying. So this is the destination file name where we will, so I will, HFA was already created. So I am defining a file name. So the image will be stored in this location. So for that driver dot first thing, now there we use driver dot create. Here we will use driver dot. So you can get the help about this function. So this is the description of driver dot create. It takes the following arguments. First is the path. Where do you want to store the file? So here I have passed it destination file name. Then X size. What is the width of the image? Y size, height of the image, and how many bands you want to write in an image, and what is the data type of the numbers in an image, integer, float, unsigned integer, 8-bit, 812-bit, or 16-bit. So here I have defined destination file name. I want to write an image of 512 by 512 size, single band, it has a single band, and a byte, 8-bit data I want to write, 8-bit unsigned integer I want to, every pixel intensity is represented in 8 bits. So this creates a destination data set. So this creates a data set, on that we can write the image. Now here I have created a transformation information. So this is an array. So first x0 is the coordinate x, top left x coordinate. This is the x coordinate. This is the pixel size in x direction. If this number is how much the image is rotated. And this number represents what is the y coordinate of the top left corner. And this is the how much image is rotated in y direction. And this number represents the pixel size in y direction. So this is the transformation information. With that, any pixel's coordinates can be calculated. So this is in meters. So now for attaching, this is the geo transformation information. Now we need to create a coordinate system for the image. So for that SRS OSR dot spatial reference, this will create an spatial reference object. So this is a UTM 11. So this is some, just randomly I have chosen on UTM 11. I want to write the projection. I want to project the image in UTM 11 north. And then we set well-known GeoGCS datum is WGS 84. So this creates a spatial reference system, and this creates a transformation. So these two coordinate system and transformation information together are used for projecting the image on a map. So without this also you can write the image, but if you try to project the image on map, it will show that missing spatial information, so it will not be able to project it on a map. But like a normal image, it can be opened. So these are some random transformation information, and this I have defined. So now on this set, like in first example, I showed get geotransform. Here we will call set geotransform. So this will set the geotransformation, and this set project, like get projection, this is a set projection. This will set the projection of the image. Now here I am just generating a few random numbers in range 0 to 255 of 5 by 512 by 512 size. So you can see these numbers are generated. So these are the random pixel intensities. Now suppose if you want to see how the image will look like. So these are some random number. The image, if we store it, the image looks like this. So after that, same way, on the destination data set, we get it in which band we want to write. Suppose if we are writing a multi-band image, then get raster band 1, 2, 3, 4, 5, whichever band we are retrieving. So get raster band. And then on that band dot write array, the array we need to pass to it the array that it writes the image. Then after that, the same way flush cache and delete the data set. So here it must have written the image 22. This is the image. You see, this is some random numbers we generated and wrote them. It's the same way, and it has special information also. So this is the special information about them. These are the extents of an image, initial points what we stored. So 44720 and 3125. And this way we can geo-reference the image. Now suppose you have different images, all the grayscale images in different bands. Now I will show you how do we stack the images. So we want to create a true color image from the red, green and blue. We want to combine 3 bands to create 3 or multiple bands to create a composite image. So here I will combine these three files, band 4, band 2 and band 3 to make a colored image, true color image. So I first made a list of file names. Then I will be writing this to our destination list3-color.tif. It is already available here. I'll just delete it. So I'm defining a file name in which I will write. So for same way, driver, I will merge these bands together and stack. So get driver by name your geotiff image. Get driver by name first thing. Then I'm creating a destination data set. driver.create destination file name, whatever I have listed color.if, then I will make it one because these images are of size 1151 by 1151 and get this information. So, but here anyway, I already know, so I have just assigned it numbers. Otherwise, for simplicity, I have just directly assigned. Otherwise, you can read the particular image, get the information, X and Y coordinate, this X size and Y size, then you can pass on here accordingly. So here, destination file name, Y size, and here I have defined 3 bands. Earlier, all images were single band. This is a 3-band image. And data type, I have defined it to be unsigned 16-bit integer. So with this, we'll create a data set. Now, this is a for loop. We will iterate over these file names. So for file in input files, file name equal to these files are stored in Gangotri list3 folder. So this name I will attach. This name will be attached to the file. So with that, suppose if you just run this, we'll get the full file name. So this statement gives the full this construct the full file name path. So files are stored in this directory. So this step is for this purpose only. So first thing I am construct the file for reading JDAR with JDAR.open. Then I am fetching its first band because all those images are single band images. Then read as array. Here both the functions are chained together. Earlier we were doing get raster band. In the next step we were reading is an array. So here I am just chaining both the things together. So get raster band 1 and then read as array. So this will give a numpy array. This will read an image. Now destination band will get destination data set we have created. So destination data sets we will get 1 by 1 band. So index initially it will be 1. So first time it will fetch the band 1 from the image, from the output raster, because here this number is always 1. So from the source data set it will always read band 1, and destination data sets band will keep on changing. First it will band 1, then when the second loop band 2, band 3. So destination band is equal to dataset dot get raster band 1, and finally destination band dot write array. So this will then in this destination band will write this data whatever we have read. Keep on one by in first band first image, second band second data set will go, and in the third band third data set will go. So with that you get a true color image. So here you can see that we have not attached any special reference information to the image, so it was showing that there is special reference is missing. So with this it cannot project the image on the map. Only thing it can display the image. So this is the true color image created from the 3 single band images. Now I will show you how do we attach a color table to image through Python. So earlier I showed you a single band a grayscale image, in that suppose this is a classified image. In image contains some numbers. One may represent some grass, second may represent different type of trees, or third may represent something else. So suppose if you want to show the attach a color map to an image, like one number, all the wherever whichever pixels have the value 1, that should be shown in a green color. Wherever 2 are there, it should be shown in a red color. 3 are shown in green color. So this way we can attach a color table to an image, so the image gets displayed uniformly everywhere. So this is suppose this is a fire output. This is a cropped image. This is an image. See, if you see it here, it shows just some black image. Now we'll attach a color table to it, so that it will show that whichever pixels values are 1, those will be shown in a different color. Number 2s will be shown in different color. Number 3s will be shown in different color. So if you put this way, we can attach a color table to image. So first thing, I have file name and a destination file. Where do I write the image after attaching color table to it? So first we will read the image. Then I am creating it same way. I will write the image after attaching color table to it. Same way, get driver by name and create copy, because here just I want to copy the finally this my cropped image to the image with color table. Only just I am attaching a color table to image. So instead of using create, I am using create copy. So I've created destination dataset. Then destination dataset dot get raster band. So I fetch band 1 from the image. Now I create a color table with GDAL dot color table. So this creates a color table. So in this color table, we need to put entries. So colors dot set color entry. So color table dot set color entry. So wherever number is 1, so this will be represented by white, 255, 255, 255, R's value. And wherever number is 2, this will be represented RG, green color. Wherever number is 3, these are the different combinations of R, G, and B, their intensity values. So with this, the image is classified into 5 numbers. Some pixels has the value 1, some pixels 2, 3, 4, 5. So accordingly, wherever pixel is number 1, this will be represented in white color. Number 2 will be in green color, 3 in G and B combined together, 4 in red color, 5 also in red color. It's different density. So with this, we create a color table. Now in that band.set color table, band.set color table, here we need to pass the argument color table. So band.set color table colors and set color interpretation. Now how these numbers will be interpreted? So we want these numbers to be interpreted as a palette index. So set standard palette index. So set color interpretation. So after the image is created, we flush cache and write the image. So if you see after this, an image is created like this fire map. Now the image is, so this is the same image with attached a color table. So now this image will be displayed uniformly, whether you show in Windows Photo Viewer or some QGIS software. Anywhere you can see it, it will get displayed in the similar way. So the same image gets displayed in the same way everywhere. Now suppose you want to create a mosaic of image. You have 3-4 images that are of the different parts of the image, and now you want to stitch all the images together. But for mosaicing, you need all the images must be geo-referenced. Means all the special reference information must be attached to the image. Otherwise, you will not be able to mosaic the images. Here I have 4 images, so that I will be showing how do we mosaic. Here you can see these are the 4 different images. So in Python with using ZDAL, I will show you how do we mosaic images and create a single mosaic image. So now here I will just use a different library, path library. So here that makes easy to handle multiple file names. So instead of defining file names separately, we can retrieve all images ending with the TIFF name or whatever filter you can put, and you can get the all images. So here I will use a pathlib library. So here I have defined a directory, my directory name, G drive Gangotri list 3 data. Here my all the TIFF files are available which I want to mosaic together. So this is my directory name from where I will read the data, and destination file name I have given this, it will be stored in this directory name dot join path. So in Gangotri list 3 data and Gangotri list 3 data mosaic.tiff, with this name the image will be stored. Now suppose if I want to get which all the TIFF files are available in this particular directory, so I want to get the all file names, so I can use this function. So directory name is a path. This is not single string, this is a so if you do this, this retrieves all the files ending with .tiff name in this particular directory. So if we see here, these 4 files. So directory name dot globe, this is a function which retrieves, so all any file name starting with any name and ending with at .tiff. So it will retrieve, it will get all the file names, their names. So first I am retrieving the names. So file names directory name dot globe star dot tiff. So now I have data set, a list of data sets. I will read one by one all those 4 images and then mosaic together. So this is a for loop, like I have shown you. For this enumerate function, this is like this will generate an index number ranging from 1 to file, how many files are available in this. So I am iterating over the file names. So file names, just as I shown you here. So if I use in this, I will explain you how what it is. So this enumerate function generates an index also with this. So if you use enumerate files, it will give the name of the file which it is enumerating, and then it will generate an incrementing number. So for that I have used this enumerate function in this function. So this will generate a number so that I can use band number which I have to retrieve. So first thing, I'm iterating over the file names which are available, iterating over all the files. It may have 3, 4, 5, 6, whatever number of files are available. It will read the files one by one. So first I am dataset chidal.open that particular file. It will open the file for reading. Then these dataset I am appending to a list so that I know that I have read these much dataset. So that later on these all can be combined together. So dataset in the dataset is a list. In the data list, I am appending all these read datasets. So dataset dot append this dataset. Then I am reading this dataset numbers from the array. So dataset dot read as array. Now I will just show you. This will just plot an array, and this is collecting all these dataset together. So if we see this, so these are the 4 images which we are supposed to mosaic together. So these are the 4 different images. So these 4, now we will combine these 4 images together and make a single mosaic out of these images. For that, so here we have read the images and combine these, all the data sets, all the images we have kept in a list, an array. So that array we will use for mosaicing. So for mosaicing, we will use Zidal's warp function. So Zidal.warp. So it takes minimum 2 arguments. Third is also optional. So first argument we pass to the image is destination image name. Where do you want to store the image? And second is the source file name or source data sets. Then third is the format, in which format you want to save the image. There are multiple options available to this. So if you can customize the way you want to save the image. So here we have this is the complete information about the warp function. You can do many things with this. Even you can crop an image, subset image, mosaic multiple images. So these are the different options you can pass to the image. You can go through it and do it. This is quite powerful library. So Zidal.warp mosaic. This is the destination image where we want to save the image, and data sets. These are the input images which you want to mosaic. And this is the format, in which format you want to save the destination image. So because here we have .img, so for img's short name is HFA. So I need to pass it in HFA, or if I want to save it in TIFF, I want mosaic.tiff, and format I need to pass it GTIFF. If you don't pass the format argument, then by default it takes that TIFF. And it returns, this warp returns a mosaic image as well. Mosaic image data set it returns. So suppose if I mosaic, now suppose if I plot this mosaic, this shows a mosaic image. So here you can see that these 4 images are combined together in a single image based on their location on the map. So here you can see that in this graph, this image is coming below this image here, but while mosaicing it has come properly put it in the correct location because its coordinates are starting from this point onwards. So it has mosaic correctly. So with this way we can mosaic the images together. We can crop the image using a save file and so on. So this is all about what I was supposed to cover.